Hi everyone, I would like to welcome all of you to Frontline Systems webinar on data mining using XLMiner Platform, our advanced product for building predictive models. My name is Dr. Sima Maliki. I am Consulting Lead and Modeling Specialist at Frontline Solvers. During this presentation, if you have any questions or comments, please type them into the chat box to be answered at the end as time allows. I strive to remain within the promised time frame, yet to thoroughly cover all the material, sometimes it takes a few minutes longer. I very much appreciate your cooperation. Almost every action in your business generates data. Your sales transactions, customer interactions, even clicks on your website. This data can be a valuable strategic asset when used in your decision making. This is accomplished with data mining. Data mining allows you to find and extract useful information and discover patterns from your large data sets. XLMiner is a powerful tool for you to gain insights from your data via data exploration, visualization, forecasting, and data mining in Excel without any need for programming. And this is a time saver to help you get valuable results quickly. Today, we explore how XLMiner Platform can benefit you and how easy it is to use. Together, we'll review typical applications, including data analysis with visualization, classification tree algorithm for classifying wine samples using the boosting Ensemble method, text mining to process and analyze two internet news groups, and feature selection. Then we'll forecast using time series, smoothing techniques, the number of passengers for an airline. Before beginning in XLMiner, I would like to share some useful information with you about data mining steps and supervised and unsupervised learning algorithms. Let's start by talking about the types of data. As you know, there are several types of data. Your database may include the gender variable, which can be recorded as male or female, or your sales variable could have high, medium, or low values. These are a couple of examples of categorical variables. Every unique value of the variable is a separate category. And there is another type of data that is numerical. This is like money, age, or any other continuous variable. Now on to data mining steps in Excel using XLMiner. First, you identify a problem you want to solve or an opportunity you would like to leverage. Next, you collect your relevant data. After that, you need to understand your data. What I mean by understanding, for example, is find out what types of data are there, what units are the data in. Then use exploration and preparation. Data exploration is essential because databases do not automatically reveal patterns and insights. So, organize and subset the database, use summary measures, or use visualization to examine individual variables and also to identify relationships among multiple variables. The preparation step can include handling your missing data, binning your continuous data, or transforming categorical data when there are too many categories and you want to group them into fewer categories. Once you have a clear understanding of your data and it is prepared based on your project needs, you can identify the best data mining approach to use. As you can see, data mining approaches can be separated into two categories: supervised learning and unsupervised learning algorithms. Unsupervised learning methods do not try to predict an output value. They are used to detect patterns and relationships in the data. In supervised learning, the goal is to predict an outcome based on a set of features. No matter which you use, the next step includes building your model using one of the techniques such as classification, prediction, or association rules. Unsupervised learning methods such as cluster analysis, principal component, and association rules all offered in XLMiner detect patterns and relationships in the data. They do not seek to predict an outcome. Market basket analysis is one of the applications. Having huge databases of customer information and using unsupervised learning methods, you can discover market segments and group your customers into these segments. Then you can more efficiently sell or market your products. Social network analysis is another application. However, in supervised learning, the goal is to predict an outcome based on a set of features. The outcome is generally referred to as a dependent variable, response, or target. The features that are used to predict this outcome are referred to as inputs, predictors, or independent variables. Supervised learning includes classification and prediction methods. Predict enables you to identify a value for a continuous outcome, such as predicting a fair market value of a house or how many units of your product a customer will purchase in the future. Classify allows you to predict a discrete categorical outcome, such as if an online transaction is fraudulent or not, whether an email is spam or not, or if an insurance applicant is a high, medium, or low risk. Now, we are ready to briefly walk through XLMiner Platform features, starting with sampling. Sampling tools in XLMiner enable you to draw a sample of data from virtually any external database, such as Microsoft Access, SQL Server, IBM's DB2, Oracle, and Power Pivot. Furthermore, you can get a sample from Apache Spark big data compute clusters. And you can import a sample of text documents from a file folder to mine for insights. Most of you would agree that Excel provides ease and speed for building models, and it is familiar to everyone. You can also use Excel for all your analytic needs, and this permits some synergy by doing them together. And Excel is such a good database client and very powerful. With Microsoft's Power Pivot adding a full database underneath spreadsheets, you essentially have SQL Server in the memory with Excel. This allows you to apply data mining methods to your large datasets using XLMiner. With Power Query, you can extract, transform, and load data from a huge range of sources, from enterprise on-premise databases to cloud-based public data stores on Windows Azure Data Marketplace. And Power Query and Power Pivot are actually in the box with Excel 2013, and you just have to activate them. To review the remaining features of XLMiner, let's switch to Excel. Here is the XLMiner Platform ribbon you can use to apply the full power of data exploration, visualization, and predictive analytics. Here I have installed Analytics Solver Platform, and XLMiner can be installed as an individual product or as a component of Analytics Solver Platform. So we just talked about sampling tool or get data in XLMiner. The Explore tool allows you to visualize your data and provides you with feature selection capability. XLMiner Chart Wizard allows you to create 8 different types of charts, from simple bar and line chart to scatter plot to scatter plot matrices and parallel coordinate. Furthermore, Here you can export your data directly to Power BI or Tableau. Again, XLMiner offers a complete set of data handling utilities to clean your data. This includes missing data handling, binning continuous data, transforming your categorical data, and then principal component analysis is available here too. Here is the text mining tool, allowing you to gain insights from your unstructured text data. XLMiner includes built-in time series analysis tools. It includes the capability to partition a time series data, the ability to fit a model using a remote with or without seasonal components, and 4 types of smoothing techniques. Here with partition, you can partition your data to training, validation, or test sets using standard partition or partition with oversampling. So a model can be trained and then evaluated. This can be done using this button or partition under the live feature, which we will be using today. So we talked about XLMiner methods that include both supervised and unsupervised learning techniques. You can have access to 10 supervised learning techniques, including 6 classification and 4 prediction methods. Furthermore, you can build better classification and prediction models using ensemble methods that are accessible via cascading menus for regression tree, neural networks, and for classification, we have them for classification tree and neural networks. XLMiner's 4 unsupervised learning algorithms include the 2 clustering methods, principal components, that is here, and association rules. Now on to visualization. Let's start with opening one of the examples called wine sample dataset. To access this example and other examples, click on Help and then click on Examples. In this workbook, let's click on Forecasting Data Mining Examples. And let's scroll down to wine dataset. Here is the dataset with information about wine, including 13 variables that describe different properties of wine from 3 vineyards. We call the wines from 3 vineyards types A, B, and C. This is the wine type variable. Our goal is to assign a wine classification to each record. Let's first start using the chart wizard to see what it shows. So select any cell within the data, click on XLMiner Platform, Explore, Chart Wizard. For this example, let's choose scatter plot matrix and click on Next. I'm going to choose, for example, alcohol, flavonoids, this one, and color intensity. Let's click on Finish. So this is our scatter plot matrix. On the diagonal, we have histogram of our variables, and on either side, we have the scatter plots. Let's look at this scatter plot, the top right corner. If you pay closer attention, we could see a distinct cluster of observations. We can select the data points in this cluster with our cursor, and immediately those observations turn red, not only in this chart but also in all other charts. You can then look to the right for details on actual records. For example, it seems that all of them belong to type B. Let's remove this selection by clicking on the graph. Now let's use the color by feature to see what it can tell us. Let's choose this drop-down menu type as our variable. We can see that all of these observations belong to wine type B, which is colored in yellow. This visualization is helpful, yet it is not enough for our purposes to draw a line to classify each record as to which vineyard it belongs. So let's move on to building a classifier model which would automatically look at this data and fits a model to indicate which vineyard the wine comes from. So let me close this and show you that if you would like to save a chart, just give it a name, then click on Save, and to access the chart, click on Explore Existing Chart, and chart 1 is available here. This visualization is helpful, but it is not enough for our purposes to draw a line to classify each record as to which vineyard it belongs. So let's move on to building a classifier model which would automatically look at this data and fits a model to indicate which vineyard the wine comes from. So we are going to use the classification tree algorithm. Again, select the cell within the data and click Classify, Classification Tree. Now we have 3 boosting algorithms, 3 ensemble algorithms including boosting, bagging, and random trees. But first, let's start with just building a single tree. So single tree. Our output variable is type, and let's select all remaining variables as our selected variables. Let's click on Next. We can keep the default values for maximum number of tree levels. Here you have an option to set maximum number of split or nodes. We can keep minimum number of records in a terminal node. And here you can see that we have the option to partition the data because we haven't partitioned the data. This is our partition on the fly feature. So let's check partition data. I'm going to keep all the default settings for dividing the data automatically to 60% training and 40% validation. Let's click on Next. Here you can ask to see the full tree, and you can get the detail and summary report and so on. Click on Finish to get the results. Here's the output of classification tree algorithm. Here is the output navigator. You can use it to quickly reach to various sections of the output. For example, let's click on full tree to see the visualization of our full tree. Now let's check the validation training score summary report. And I'm going to increase the size so you can easily see the values. Here we have the confusion matrix that displays counts for cases that were correctly and incorrectly classified in the training and validation datasets. So this is the confusion matrix for the training data. You can see the actual classes and predicted classes. And here we can see the error report. So overall, you can see that there was one case misclassified in the training data, resulting in a % error of 0.9. In the validation data, there were 10 cases misclassified and that results in % error of about 14. Now, let's compare a single tree results with those from classification tree ensemble boosting method. Let's talk about these methods first. Ensemble methods can help us build better classification and prediction models. It is a technique for combining multiple weak learners in an attempt to create a strong learner by taking a weighted vote of their individual classifications or predictions. And again, these are available for 12 classification algorithms and 2 prediction algorithms, and that 3 ensemble methods are offered to you. So let's go back to our data set. Let's go to data. Let's select the cell within the data, click on classify, classification tree, ensemble boosting method. We need to select type as output variable and all remaining variables as selected variables. XLMiner automatically recalls and repeats the selected variables for us. So let's click on Next. You can see that the default selection for boosting algorithm is ArrowBoost M1. There are 3 different variations of boosting are available. The difference is the way in which the weights assigned to each observational record are updated. Now the number of weak learners is the default value of 50. We're going to leave that as 50. A weak learner here is a single classification tree like the one we just built. This will tell XLMiner to construct 50 different classification trees during the run, train each one on different subsets of data, and combine the results to get a better classification. Let's keep the defaults in the tree section. I'm going to partition data using partition on the fly feature. Click on Next. Let's just get the summary report and click on Finish. Here is the output of classification tree boosting algorithm. Let's go to Ensemble Detail. You can see that XLMiner assigns a weight to each of the 50 weak learners. Here we have the importance percentage for each variable that measures the variable's contribution in reducing the total misclassification error. And now let's scroll down to training and validation confusion matrix. So, no records were misclassified in the training data set and only 4 records were misclassified in the validation data, resulting in a person error of 5.6. As we can see, classification through ensemble methods are very powerful and typically result in better performance than a single tree. Next, let's explore TextMiner. XLMiner text mining tool allows you to process and analyze your unstructured text data so you can quickly and fully utilize the power of this data to enable better decision making. This tool can analyze text found in cells in a worksheet, fields in a database, or in separate text documents. Some applications of text mining include the ability to classify customer reviews as satisfied or not satisfied, to distinguish between which products have the least negative reviews, to extract the topics of articles, or to cluster the documents or terms. For this example, we are going to use text files from a well-known text data set, which consists of messages collected from 2 different internet news groups, autos and electronics. This text mining document data is available in the examples. It's here. So you can click on it, then save it and unzip the folder. I've already unzipped the folder, so let's close this one and let's open a new blank worksheet and go to XLMiner Platform. Now, I'm going to extract a sample of text files from the file folder. So, let's click on Get Data. The third option, File Folder, to import from File Folder. Again, XLMiner can work with text that is in a column in a spreadsheet, or text that is in a column of database, or text that is in a series of files, text files in a folder, and that is what we're going to do here. So let's browse to where I have the 2 internet news groups unzipped. So click on Browse. I have the autos here, so let's change the file type to all files, and let's select all of them and click Open. Now we are going to click on this button to move the files from left to the right list box. I'm going to repeat the same steps for the electronic subfolder, bringing files into the left list box. So click on Browse. Going to do the electronics, Set the file type to all files, select all of them and click Open. Just choose one of them, so then this button would be active, and then click on this button to move all of them to the selected files. Now we're going to get a sample, so let's choose the radio button sample from selected files. You can enter 300 for the desired sample size and keep the other remaining default settings. Now please take a look at the output section. Write file path it's selected. XLMiner can import the text directly into the spreadsheet if a single document would fit into a single cell. There are limits on the number of characters per cell. Otherwise, XLMiner can just record the file path, which is what we're going to do here because our text files exceed the limits. So let's click on OK. Now we have imported the text files. This spreadsheet XLM sample files includes the file paths, but there is no text as expected. Then during the text mining, we actually read the files at those file paths. As you can see, the name of this column, including the file paths, is TextVar. Now, on the XLMiner Platform ribbon tab, click the text icon. We are going to select TextVar in the variables and move it to selected text variables and click on Next. Here you have the option to map text variables to an existing model. So in the future, if you have new data, you want to map it to the existing model, you can use this. But let's move on to pre-processing or click on Next. Let's click on pre-processing. Pre-processing provides you with all the options that can help you eliminate common words. So text mining can focus on the words that carry the most meaning. So you can keep the default settings for stop words, stemming, and case normalization, or you can just go ahead and edit the lists that are available. Let's click on Representation tab next. Here you can see that Perform Latent Semantic Indexing is checked. XLMiner will create a matrix of terms and their frequencies. With Perform Latent Semantic Indexing, XLMiner will extract concepts from a set of documents, where a concept represents a cluster of words that tend to occur together in the text of different documents. Let's move on to Output Options tab. Let's make sure we have the concept document. Let's choose zips plot. I am going to choose the script plot and term scatter plot. And you could choose to write the text mining model. Now let's click on Finish button to run the text mining analysis. Pop-up charts will appear. Let me move them to the middle section of the screen. My mouse is giving me a hard time. Okay. Zips plot shows the most frequent words, and you can see a typical rapid drop in word frequencies. I can hover over each of these points and you should be able to see the term is right. This is rank 1, document frequency is 149. And then if you go down here, term is campus, rank is 810, document frequency is 6. So you can see typical rapid drop in word frequency. Let's close the zips plot. Script plot shows the relative importance of extracted concepts. So you can see concept 1 is the most significant. Let's close this one. Here is the term scatter plot. Concept 1 is really a cluster of words like car, drive, system, auto. Let me see if I can zoom in and you can see the word cluster of words like water, hot, cold, heat. And then you can see I can put this back so I can zoom back in. So words that more often found to occur together, and here you can see words that more found to occur for concept 2, that are closer to concept 2. Now, for example, let's choose concept 14. And you can see immediately that the cluster of words migrates over in terms of their frequency toward concept 14. So let's minimize this pop-up chart. Actually, I'm going to close this one and show you some of the outputs of the text mining processes. So let's go to TM-LSA CDM worksheet tab. This is the concept document matrix. The concepts which appear in the columns can act like numerical variables in your model, and the rows are documents which can act, and they are kind of the same as cases or observations. Similarly, we have TM-TDM. So the terms, all the terms are here. The terms are, they can act like numerical variables for a model, and rows are documents which are the same as places or observation. Therefore, the concept document matrix and term document matrix can be used as an input to any of XLMiner clustering, classification, and prediction algorithms. For example, you can use a classification method to create a classification model using the concept document matrix to classify new documents based on the text content, whether they belong to autos group or the electronics group. We just saw how you can get predictive results from text. Next, we're going to talk about feature selection. Feature selection in both XLMiner Platform and Pro helps you identify which of all the hundreds of your variables or columns of data have the most predictive power to feed into your classification or prediction algorithms. I'm going to open the Boston housing dataset. And let's increase the size. This dataset includes 14 variables, each describing a census tract within the city of Boston. Imagine that you had 100 variables instead of 14 like we have got here. A lot of these variables are going to overlap each other. Some are going to be important, some may not. You can use all of them in your classification or prediction algorithm, but it is going to take lots of time, and feature selection is a preliminary step, just like visualization is, that you can use to quickly find out which variables are most significant and then concentrate the rest of your analysis on those. So MEDV is the median value of owner-occupied homes, and cat.MEDV is a categorical variable derived from MEDV. So I'm going to focus on choosing cat.MEDV as our output variable with the goal of later building a classification model. So let's choose select cell within the data, click on XLMiner Platform. Let's click on Explore Feature Selection. Going to choose cat.MEDV as the output variable and all variables except MEDV as continuous variable. And you can confirm that XLMiner recognizes this as a classification task by choosing categorical under the output variable type. Now let's click on Next. Here you can select the statistical filters to compute Welch's test and Gini index. Let's click on Output Options. Here you can select to get a top features table. You can get the feature importance flood, which is selected by default. And this is a graphical representation of variable importance based on the measure selected here in this rank by drop-down menu. So you can see the measure is Welch's test. And I'm going to increase number of features to 5. So XLMiner displays the top 5 most important or most relevant features or variables. Okay, so let's click on Finish to get the results. This is the variable or feature importance plot, which ranks the variables in order of importance according to Welch's test. The top 5 most relevant variables are LSTAT, RM, in industry PT ratio, and tax. Let's close this plot, and you can see the detailed feature selection report. Here we are analyzing the data using several different statistical tests of their importance. By looking at how different variables are ranked according to different tests, we can get an idea whether these variables are consistently showing up as the most important or not. Then you can focus on those variables as inputs to a prediction or classification algorithm. For example, let's look at the Welch's test statistic. Let me increase the size. We are looking for the biggest magnitude. So we cannot also, however, just sort them from like smallest to largest to smallest, and we can get the magnitude, but you have to be careful. We are just looking at magnitude, so the negative ones matter too. So the first one is LSTAT, then is RM, industry PT ratio, and then tax is 8.4, and the remaining are dropping from that. They go to 7 and 6. Now let's look at Gini index. Gini index measures a variable's ability to distinguish between classes. The smaller the Gini index, the more relevant the variable. So if I resort by Gini index from smallest to largest, you can see again the top 5 most relevant are RM, LSTAT, industry PT ratio, and tax. As we saw, we can see that the top 4 or 5 variables for each statistic include LSTAT, RM, industry PT ratio. At this point, we already have a lot of useful information about our variables and their relationship to the categorical cat.medv variable. We started out with all features, and now we know rather quickly that only 5 of them basically matters the most. Now you can practice creating classification models, yet instead of using all original variables, you can use the most important ones. Now let's discuss the time series analysis. Time series is a set of observations on a quantitative variable collected at equal time intervals. Stock prices, exchange rate, consumer price index, or unemployment rate are examples of time series. XLMiner includes ARIMA and smoothing methods. Smoothing techniques smooth out random variations in time series data and reveal underlying trends and patterns. Let's open the air passenger dataset. It's actually the first one. This is the air passenger dataset. This dataset contains the monthly totals of international airline passengers from 1949 to 1960. Here we have only a time variable and a quantitative variable, which is number of passengers that is collected over time each month. First, let's use XLMiner chart wizard to explore the airline passengers time series data. I'm going to select one of the variables, click on Explore Chart Wizard, and I am going to use the line chart. Let's click on Next. Let's choose passengers for our variable selection. Let's click on Next, and on X-axis we want to have month. Then we have option to choose for color, which we don't have, panel, and then Finish. Here's the chart. As it can be seen, this figure suggests that the data is non-stationary. It has a strong upward trend, and also it has a seasonal pattern. Therefore, forecasts of future values for this time series would be more accurate if they reflected this seasonal effect. So let's close this. And now we can start with partitioning this data. Click on Partition in the time series data. Let's choose our time variable, which is month, and then choose our passengers variable in the partition data, and keep the default settings for the percentages for partitioning, and click OK. Here's our partition data. So within this data and in the XLMiner ribbon, in the time series, let's click on Smoothing and hold Winters. 3 additional menu items will appear: multiplicative, additive, and no trend. With no trend in data yet having seasonality, the third halt winters model can be used. During this practice, we use multiplicative method as the visualization of data shows a strong upward trend. So let's choose multiplicative. Let's choose months, our time variable, passengers as selected variable. Here you have the option to set the period. Let's choose a period 12 because the seasonality appears every 12 months. And you can see number of complete seasons automatically get updated to 7. You can here change the values for the different weights, and you can choose to optimize them. I'm going to keep the default settings. In the output options, you can choose to produce forecasts on your validation data. Now let's click OK. Here we can get different error measures. So for example, we get the mean square error and all other measures. So if you run different algorithm, different smoothing, you can compare the results here for validation data. And here we have the feeder model, and you can also see the forecast in this table. So you can see the actual and then the forecasted value. Now let's take a look at the time plots. As shown in the graph for training data using multiplicative model, the actual and forecasted values match fairly well. Yet the usefulness of the model in forecasting will depend upon how close the actual and forecasted values are in time plot of validation set. Let's verify this. So let's scroll to the right, and you can see that the multiplicative model captures the data very well, as the actual and forecasted values in time plot of validation set match up fairly well. This shows that our model is a good fit to our data. Now for a final recap. Every action in your business generates data, which can be a valuable strategic asset for your decision making. Data mining enables you to find and extract useful information, discover patterns, and gain insight from your data sets. And this ability to use data intelligently is a vital skill for business analysts. XLMiner gives you all the tools you need to visualize and transform your data in Excel and apply prediction, classification, and affinity analysis methods without any programming. It is just one component of Analytics Solver Platform, which is a complete tool set for your predictive and prescriptive analytics. Let's talk about our product line. During this session, we use XLMiner Platform. You can get our data mining software as a standalone program such as XLMiner Platform or Pro. It is also offered within Analytics Solver Platform or Analytics Solver Pro. Analytics Solver Platform includes forecasting, data mining, text mining, simulation and risk analysis, decision trees, and conventional and stochastic optimization for problems of any size. And Analytics Solver Pro is a complete solution for medium-sized problems. Now, if you are wondering, what is your next best step? If you haven't already registered on our website, please do so. It allows you to download a free trial of Analytics Solver Platform, which includes XLMiner Platform, and gives you access to downloadable user guide and example databases. Try it yourself and let us know if you have any questions via live chat, email, or call us at this special number for this webinar attendees. Thank you very much. I really enjoyed presenting this webinar to you and trust that it was helpful to you. Now on to your questions. If you have any questions, please type them into the chat box. Thank you. We appreciate your time. Bye for now.